Hello everybody. Someone wrote me that I screwed up tape deck by replacing capacitors. So it's not true. It's fully tuned. So I just make all measures to see it's modernized, upgraded Sony. I replaced all capacitors with Nichicon bipolar. I mean all capacitors which affect sound pass. So, for example, you may find them on the schematics. Let me show on the iPad. Okay, so you see I was replacing all capacitors which are on the sound pass, which marked with these large arrows. So you see it's 4.1, 4 or 2. Then we go further, get to the Dolby chip. So exit, so there is split. So we need to replace 420, 421, 422, 425. Go down, it's a relay switch. Go back, 427, 53. Then 54, then going following arrow. It's final cascade. We need to replace 435, and the last one 442 is from direct pass. But remember the outputs. So here we have output split. You see, remember these two capacitors, and it goes over relay, and here one more 452, and the same for the next channel. It's it will start from the 300. So that's it. So you're replacing this on the record board, and don't forget about playback board. It's the same arrows. You see, it's all are pretty small capacitors. We interested are in polar. So it's 234, 235. So this is a bias filter. It's not affect us. Go to the chip, following arrow, 222, 223. Following arrow. Okay. And here is more. 24, 27, 28. It's surrounding Dolby chip. You see, here is a split on the Dolby. It's Dolby S, and this chip is Dolby B and C. And this one is bypassing Dolby S. And here is relay switch. So that's everything you need to replace to completely change the sound of your Sony. However, it will require some fine-tuning. After you do that, let me show one more thing. So I was learning why it was so hard to make all tapes work properly. And you may see here on the schematic diagram that Chrome tape doesn't have adjustments. So that means that if we see in schematic that Chrome tape doesn't have adjustment, we should start setting levels from the Chrome tape, always. So we should be setting levels on the 400 Hz or 315 whenever, just to make sure that your source level and recording level will match. And then we should adjust bias. It's a common bias, you see this? Normal bias, left and right. And we have one more bias. Normal here and metal here. So this one is for HX Pro off, and this one is for HX Pro on. You see? So you should start from the Chrome tape HX Pro on and adjust levels and bias. So there is actually I've seen the Chrome Yeah, so here is the main one. It's a Chrome one, this one. And if you would see on the board, you would see that all are like typed with different types. Type 2, then goes type 1, then goes type 4. So you should start setting from type 2, then type 1, then type 4. And let me show results, how it will work after you complete your settings. So let's start from type 2 tape. And let's see, I'm recording currently minus 20 decibel. So on type 2, we set rec level, so it will match. So we should be setting rec level with these two blue potentiometers. You see, left and right channel, those two. But remember to set up your output levels first. When you change capacitors, you need to use one of the professional tapes with levels I have, just like set up proper playback level. Sony doesn't have adjustment for the equalization as Akai have, so we just setting up playback level, and then we are setting up recording level, and then we setting up Chrome bias first. So start recording, minus 20 decibels, switching to the tape. You see levels, it's a source, it's a tape. It's being set up, so it's recording, it's a tape. I will make sure that you would see both oscilloscope, generator, and multimeter. So it's 1 kilohertz currently. It's 2, 3, 4, 5. You see, arrows are almost intact, like half decibel difference. 6, 7, 8, 9, 10, 11, 12 kilohertz. 13, 14, 15, 16, 17, 18. It's still in phase. It's 18, and it's perfect. Plus 1 decibel on 18, 19 plus 2 decibel, 20 goes back, 21. Tape became not so stable. 22. It's still like zero drop, you see. 23 is minus 2, minus 3 decibel. So it's a limited Chrome type tape, type 2. It's limited by 23 kilohertz. But we can record more and it still will be in phase. 24, 25, 26. You see, I just need to improve sensitivity. Sorry, my tapes just fall down. Let's improve sensitivity of oscilloscope. You see, it's still in phase. 26, 27, 28, 29, 30 kilohertz. It's still recording. However, levels would be not the same. We can see it goes like, or drop about 15 decibels. You see, on 30 kilohertz. So it's not usable, but just for the case that it's possible to record. So it's a source and it's tape. You see, it's recording. Go back. (20, 19, 15). So 15, 10, 9, 6, 1. Okay, it was Chrome tape. You've seen it's fully linear, and adjustments are in the middle. Okay, it was TC-KA5ES. As for the normal type, I'm using TC-KA5ES. Unfortunately, I don't have Max LUD1, which is recommended. But most of my tapes TDK-D90 and Sony HF, so they're very close. The TDK has a little bit like 1 decibel better response, so I can use this one to set it up. These days, like, we're using tapes we have and on the tapes we should. Okay, so I'll start the recording. 1 kilohertz, see levels. See, it's a little bit drop in the levels, like 1 decibel. That's we are correcting on the front panel. All right, here we are increasing level, so it match the source. Now, source tape intact, good. And let's see how type 1 will perform. So 1 kilohertz, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, you see? Still 0 drop. 16, 17, started to be less stable, but still in phase, still works, 17 kilohertz. 18, probably 18 minus 2 decibel is probably the maximum we can do with this tape. But it's type 1, so 19, 20, it's a drop, it's still recording, 21, 22, so it's not very usable. But you see how linear response is with these new capacitors. Okay, let's change it to the TDK-MA. So we set in TDK-MA tape. I don't have 60, I have the single MA 110. But I compared results with Sony XR60 and it's pretty close match. So let's return back levels. Let's start recording. Switch to the tape. You see a little bit drop. Let's correct it on the front panel. Okay. So source tape equal. Let's see response. So it's 1, 2, 3, 4, 5, 6, 7. You see, like about 1 decibel higher. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Still flat. 21, 22, 23. It's still flat, 24, minus 3 decibel. So metal tape up to 24 kilohertz. And to make everything clear, let's do one more test. Let's see how our calibrator, so it's TDK-MA. Let's see how calibrator will show results, the same we've seen on the milliwatt meter. So let's start calibration mode, recording, bam. So it's tape, use it one. It suggests a little bit add on the level and remove in the middle. So remember those 1 decibel we've seen there, and a little bit on the frequency response. Okay, almost there. Just not very stable tape. Okay, done. And that's the difference. Remember this 1 decibel in the middle, right? That's the difference. It's a small correction. Is believed that on the highs, it just needs a little bit less bias to make it more linear. And we need to add a little bit more level. So it's been 1 o'clock, it's now 1:30 o'clock. Okay, let's check recording and let's see how response will change now. So it's a source. tape. You see one channel is not very stable. It's 110 tape and it's quite old. But let's see if there will be a difference. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see, it's linear. 11, 12, 13, 14, 15. The left channel is not very friendly, so it's tape been used for many years. 16, 17, 18, 19. So you see 19 a little bit higher. So this calibration really works. Adjusting equalization helps to maintain response linear. So as you have seen yourself, this record equalization reduces this bump in the middle and makes a very linear response. We may check two other tapes what the difference should be there, right, according to the deck calibration. So going into calibration mode on the chrome tape is believe a little bit less bias, a little bit more level, and a little bit on the equalization side. Okay, let's see how it will perform on the chrome tape. It's a battery tape, it's recently opened. So it's 1 kilohertz, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You see, after 18 kilohertz a little bit increase, 19, 20. But up to 18 kilohertz we are completely flat, like less than half decibel difference. That's how calibration works. And the last one would be the normal tape. We use it initially. Let's set everything in the middle. Turn on calibration. So you see it says that we need add level. And that's it. It's pretty good tape. You see response is flat, bias is flat. Bias, actually set up bias on this tape. Just on the response, it should be pretty linear. So it's 1 kilohertz, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, flat, fully flat, 16, 17, okay, 18, up to 15 kilohertz fully flat on type 1. That's pretty good results, but it's minus 20 decibel. I tried to reproduce on minus 10 decibel. Unfortunately, it cannot do the same trick as Nakamichi. So Nakamichi can hold 2018 on minus 10 decibel. Sony cannot do that. So I can demonstrate you what would change. Let's switch to minus 10 decibel here. Let's do minus 10 decibel recording level. So it's currently 1 kilohertz playing. So you see level basically 0. See source tape, and let's see what would happen on minus 10 decibel. So 2, 3, 4, 5 flat, 6, 7, 8, 9, 10, flat. 11, 12, 13, you see, it starts to drop. 14, it's minus 3 decibel, 14. 15, okay. 15 is unusable. So it's still good, it does everything it could. But that's the difference with the Kamichi I discovered. Thank you. Thanks for your time watching that. I hope you enjoyed.